we're going to look at. Express 1 over 1 minus x all squared as a power series. What is the radius of convergence? Now this is definitely one that, if we look back at our last strategy, it wouldn't work. Because in the end, I need to write this as 1 over 1 minus something. But this extra square here on the outside is going to stop us from doing that. So this is a function where the last strategy wouldn't work. So what I'm going to do is I'm going to look back at the original power series we started with at the beginning of class. 1 over 1 minus x. So 1 plus x squared plus x cubed and so forth, which we've written as n equals 0 to infinity, x to the n. So what I want us to do is take this function here, this 1 over 1 minus x, and take its derivative. So let me call that function f of x. Okay. Let's call that f of x. And now I'm asking, what's f prime of x? You know how to find the derivative of that? It'll be what? You could do that. That works. Do the quotient rule. Or another way you can do this. This numerator's fixed, right? It'll be 1 minus x to the negative first. That's how I can rewrite that function. And now we just do the chain rule. I think what you were thinking of, natural log, is what we get when we integrate the function, right? When I integrate. Yeah. So let's take the derivative using the chain rule here. What do I get? Negative 1, 1 minus x. What's my new power? Negative 2. Is that the derivative? No. Multiply by the derivative of the inside, negative 1. So if I simplify this, negative 1 times negative 1 is positive. Hey, that's the function we started with in our problem, right? This is what we wanted to find the power series of. So I just need to find the power series of f prime of x. But we know how to do that. I go back to this power series of f of x up here. And I just take derivatives of all these polynomials over here. And that'll be the power series for f prime of x. So f prime of x, its power series, I'm going to take derivatives of the one. So the derivative of 1 is 0. The derivative of x is 1. X squared, 2x. X cubed, 3x squared, and so forth. So the power series for this would be the sum n x to the n minus 1 you just take derivatives. And f prime of x, we said this is 1 over 1 minus x squared. So here's my power series representation for that function. Okay. I think the last thing the question asked was for radius of convergence. Well, everything we did, let me scroll up so we can see, everything we did was based on this original power series representation here. And I know for this one, the interval of convergence is -1 to 1, which tells me the radius of convergence is 1. And I said when you take a derivative or when you integrate, your radius of convergence stays the same. So down here, this power series has to have the same radius of convergence as that one. So my radius of convergence is r equals 1. Okay. So this opens up a whole new world for us, because we're still basing it off of that same 1 over 1 minus x, but now I can take derivatives and integrate. If I already know the power series, I can take derivatives and integrate to get new functions, to get new power series representations for functions.